A quick apology before we begin. When your air conditioner breaks in Florida in June, you don't have a lot of time to set up tripods and lighting and whatnot to do a YouTube video. So I had to do a lot of extra cleanup, editing, stabilization, audio post-production. You may see some artifacts in the video. I just wanted to point that out. If you're good with electrical work, you could save a lot of money knowing this stuff. If not, there's enough current going through this air conditioner to kill you dead. You do not want your air conditioner mentioned at your eulogy. That's my warning to you. Pay that AC guy today and take an electrical class as a night class or something as a lesson learned. My wife had complained about an increase in temperature in the house that was accompanied by an odd smell that came from the vents the night before. On our thermostat, looking at it midday at the time, the attainable temperature, it was about 4 degrees, 5 degrees difference at that point. So clearly the AC wasn't doing anything with regard to cooling. So now as we're actively monitoring it to test, I look up here at the pickup, we turn on the AC, and I don't feel any air sucking up. I don't hear any air sucking up into the filter. It would stand to reason, obviously, if it's not being pulled up. There's no air blowing out any of the vents. I was kind of surprised when I went outside and I saw the blower was working fine over the compressor. But I had just recently replaced a capacitor in this, though, where I did a video where I diagnosed the problem with this with a cable tie. You know, companies want to sell you an entirely new compressor or a unit and whatever, charge you $1,000. I ended up spending $35 to get this unit working again. Link up above in the top right for that video. But as I look at the pipe, there's no water coming out of the pipe. Let's take a look inside, see what we got going on. I've pulled the covers of my AC unit and taped over the dummy switch to make sure the AC unit remains operational. I would strongly encourage people not to do this, but what I could hear is an audible hum coming from the fan, and the fan is not spinning. That hum to me is a telltale sign. I then ripped the tape off of the dummy switch to cut power to this unit, and we're going to take a look deeper at what the problem could be. It's dried out now, but yesterday this area was completely filled with moisture and it was very cold because this was acting like a refrigerator. The compressor seemed to be working just fine because there was nothing wrong with that portion of the circuit, and it was generating a lot of cold air with no blower to push it anywhere. It was just all accumulating in this area of the air conditioning unit. First order of business, because none of this is worth dying over, going over to the side of the house, and I'm killing the breaker for my AC. I'm going to stress that this is my 230, 240 volt breaker. Don't skip this step. Reason why I stress that, you'll see me hit that dummy switch. We'll look at the board. There's an LED on there. The LED lights up. We still got 120 volts going to this board because there's another circuit breaker in this house for 120 volt service. If you didn't know that, you could be putting your hands right into a live panel. So I'm going to kill this breaker now, and now I should be good to go. Do that test again, because I'm not going to put my life into the hands of somebody who wrote something on a panel with a pencil. But now I could see the LEDs not turning on. Safe assumption, there's no power. To rule out the simplest mechanical binding, I'm just going to reach back into the fan, spin it like so, and see that it spins freely. If it's not spinning freely, if a bearing got messed up, something got stuck in it, you know that the fan needs to be replaced or at least addressed. Mine didn't appear to have any of these types of issues. If you look over here, you'll see all the cables that come from the fan, including this little green ground that goes right to the chassis. And they make their way all the way to this controller board, which any AC company will be happy to sell you at $150 plus 30% markup. But there's also 2 other red cables right here, and they go to an electrolytic capacitor. In my case, a 10 microfarad, 370 volt rated capacitor. And that capacitor is required to spin over the motor, without which you get a telltale hum. Interesting note, when they sell you the board you don't need to repair this problem, they're also going to sell you the capacitor too at 30% markup. So the $10 capacitor, you're going to pay more for as well. I'm getting ahead of myself though. Why don't we rip this capacitor out and see what we got? I'm shorting each terminal of the capacitor to ground in case it has a stored up charge. This is a safety procedure. When you work with stuff like this, you really got to know these things. You don't want to shock yourself or injure yourself. It's another warning I have. Just shorting it to earth to make the potential equal. And I realize I do not polish the inside of my garage-mounted Florida AC unit with carnauba wax, but nonetheless, I'm loosening these screws here. There are 2 of them that are going to move this board out of the way to allow me to access the capacitor. With the other screw removed, we're going to be dislodging this and lowering it with great care because there are many wires connected to this board in many different directions. My board is now safely lowered out of the way, and you can see that I now have easy access to work on the capacitor, which is 6.5 millimeter bolt holding in the bracket. And removing that bracket releases the capacitor. I remove that bracket from the capacitor. Very easy, and there it is. That's what we're looking for. Carefully remove the 2 red wires from the capacitor. It doesn't matter where they were connected on the capacitor because it's non-polarized. We're going to take this capacitor now, put it on the bench, and see if it's actually broken. I hooked this up to an LCR meter, and immediately I'm seeing 0 capacitance on this thing. It's telling me it's just an open. When you see 0, you got to verify your equipment, so I hook up another capacitor. The equipment's working just fine. If you have a multimeter, the only thing you could really test is a short, but mine is showing open, and if it's really an open like broken, like mine is, it won't indicate a problem. Hooking it up to an ESR meter is absolutely conclusive. The thing is dead. Now, what you can do if you don't have an ESR meter or an LCR meter, you could go down to your local electrical store, not big box store, not Home Depot, not Lowe's, your local electrical store, have them test it for you, and then buy your new one from them. If you do go the big box route, you could buy this shady ass one with no label from Lowe's for $5.50, and look forward to watching this video again next year. The quality on Amazon does improve, but watch out for no-name brands, buyer beware. Get something with at least an electrical rating. Whether that capacitor is good or bad, we still need to make sure that the windings going to the fan are still all good. We're going to test them now. We can see there's one common white wire, and then we have these remaining multicolored wires. They're associated with different speeds as shown in this diagram for my air conditioner. I've temporarily reseated the circuit board back onto the chassis so I don't damage anything when I work here. We're going to take note of the positions of all these cables on the circuit board to include the common. So now I'll detach common from the board. And then I'll detach all the rest of them from the board. Notice that there's also a fuse here. We'll be testing that as well. I've set my multimeter onto ohms. And then I've connected one side of that multimeter into common. We're going to be looking for several ohms, no opens, no shorts. Blue is 5.8, that's good. Red is 6.6, that's good. Yellow is 5.1, that's good. And black is 4.4, that's good. All of the windings appear to be good. Switch over to continuity diode mode. I check the fuse, appears to be good. This portion of the test is now completed. With the fan and fuse test completed, I put the wires back exactly where I found them. If the fan test failed, you'd most likely be looking at a new fan. New capacitor has arrived, but I'm not just going to throw it in, I'm going to test it. We can see it's 9.77 with a 6% plus or minus from 10 microfarads, so this is definitely good. For those who want to see a brand new one on an ESR meter, we're looking at about 0.08. So I reconnected to those 2 wires. The polarity doesn't matter. And I'll put it back in the bracket and screw the bracket down. I definitely don't want to test it with it hanging. Everything needs to be reassembled. This includes the main circuit board, which I've remounted back onto the chassis. Before I continue and apply power, I want to address issues that I find like this cable. This is bad enough that I'm going to spray it with deoxit before I remove it. Carefully pried it off with a screwdriver at the base. I didn't pull it. Use some fine sandpaper to clean the contact on both sides. Reconnect it a couple times to clean the surface of the connector. Then I'll permanently affix it and hit it one more time with deoxit. Do that with any shady looking connections. If your AC has a diagnostic like mine, you'll probably want to disconnect the thermostat before applying power. My thermostat power is connected via the port labeled R. Clip a lead to my test terminal, have it at the ready. For the test, the dummy switch will need to be actuated with tape. With all tools and fingers out of the way, I turn 120 volt service only back on for the air conditioner. We can see the power LED is on. I'm going to put the air conditioner in test mode. The technique for your AC may vary. I encourage everyone to do this. LED is going to blink out a code, and then it's going to begin. First, we see the inducer motor turning on. Now the igniter's heating up. At this point, the fan just kicked on for the heater speed of the fan. Now the fan just kicked on for the AC speed for the fan. Upon completion, there were no blinking lights. That means there were no codes. All tests cleared. This air conditioner has been brought back to full service for $10. So I've killed the breaker again, and I'm going to peel off this piece of tape on the dummy switch, pull off my test cable, put my thermostat lead back on R, drop my covers back on the units, and turn the 120 volt breakers back on. Make my way outside and turn the 230 volt breakers back on. At the end of the day, though, this is the moment of truth. Will the house get cold? Does the whole system work? Perfect, we're golden. Yeah, that about wraps it up. We've hit 75 degrees, we're good. I hope you found this video enjoyable, entertaining, informative. Hope it helped you save money. Hit that like button down below, helps me out a lot when you do. Hit that subscribe button for more episodes. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?